Okay, we're going to work on the review for our Unit 2 test. First question, solve the following system. We can solve in any method, elimination, we could do graphing, we could do substitution. This system is already solved for a single variable, so that suggests substitution would be the best method. So I'm going to substitute into the second equation. I had x plus y equal to 3, so I'm substituting this first one in for the y. So I will have x plus x minus 1 equals 3. Adding these together, I've got 2x minus 1 equals 3. Add the 1 to both sides. I've got 2x equal to 4. I need x by itself, so I'm going to divide both sides by 2. My 2's will cancel, and I've got x is equal to 2. I need to solve for y also, so I'm going to use this x equal to 2 and plug it back into another equation. So y is equal to x minus 1, but instead of the x, let's substitute our value of 2. Thus y is equal to 2 minus 1, which is 1. And my solution now is 2, 1, and I always want to check that by plugging it into both equations. So if I plug it into the top equation, I will have 1 is equal to 2 minus 1, 1 equals 1. Yes, that works. Plug it into the bottom equation, x plus y equals 3. So x was 2, plus y is 1 equals 3. 2 plus 1, check, that equals 3. So my solution is indeed 2 minus 1. Okay, problem number 2. We need to solve another system of equations. This system appears to be set up to do elimination. We've got both systems written with our x's and y's on the left side, which tells us it's in standard format. So we have 5x minus 2y equals negative 10, 3x plus 6y equals 66. None of my values have the same coefficient, so I'm going to have to multiply at least one equation by some amount. To get my x's to cancel, I would have to multiply the top by 3 and the bottom by negative 5. To get my y's to cancel, I would have to multiply the top equation by 3, and I don't need to multiply the bottom equation. So I'm going to use that. We're going to take our top equation, we're going to multiply it by a positive 3 with my goal of eliminating the y's. So 3 times 5x is 15x, 3 times negative 2y is negative 6y, and 3 times negative 10 is negative 30. Notice that I distributed to every piece of the equation. I now will add these two equations together. 3x plus 15x is 18x. 6y minus 6y cancels, and 66 minus 30 gives me 36. Divide both sides by 18, and I get x is equal to 2. I'm now going to go back into an equation and solve for y. So we had 3 times x, and in this case x is 2, plus 6y is equal to 66. 3 times 2 is 6, plus 6y equals 66. Subtract our 6, and we've got 6y is equal to 60. We now need to divide both sides by 6, and we get y is equal to 10. So my solution here was 2, 10. And again, I should go back in and check this in both equations, substitute the 2 in for the x, and a 10 for the y's. I will let you do that on your own. Okay, and let's go on to question 4, as I seem to have missed this one on the review. 4 and 5, let's do together. So we've got some coins, or Walter has some coins in his pocket. 30 coins, they're quarters and nickels. So let's go ahead and say x equals our number of quarters, and y equals our number of nickels. So we know that the total number of our coins is 30. So that means x plus y equals 30. That one's pretty straightforward. Our second equation has to do with the value of the money. The total of our coins adds up to $4.70. So it's the amount of our nickels, or our quarters, multiplied by their value, which is 0.25, plus the value of a nickel times the number of nickels. That equals $4.70. This is our system of equations. So that's the answer to number 4. For question 5, we need to figure out exactly what the answer is. How many nickels does Walter have and how many quarters? So we'll take our system of equations, and even though this is set up for elimination, I don't like all these negative or all these decimals. So I'm going to take this first equation and solve it for x. So x plus y equals 30. And the reason I'm doing this is so that I can do substitution. So if I subtract a y, I now have x equals negative y plus 30, a single variable, and I'm going to plug that into the first equation, our second equation. So I'll have 0.25 times negative y plus 30, still going to have decimals, plus 0.05y equals 470. Even though I don't like them, we could do them. So 0.25 times negative y is negative 0.25y. We now have 0.25 times 30, which gives us 7.5, plus 0.05y equals 470. Okay, we've got to combine our like terms, so our y's. Negative 0.25y plus 0.05 gives me a negative 0.20y plus 7.5 equals 4.7. I need to solve for y, so let's subtract the 7.5 from both sides. I've got negative 0.20y, those cancel, and 4.7 minus 7.5 gives me a negative 2.8. Last step to solve for y, I divide by negative 0.20. That cancels, so I have got y is equal to negative 2.8 divided by negative 0.20 is going to be a positive 14. I still need to solve for x, so I come back to one of my original equations, x plus y equals 30, and I'm going to substitute 14 in for y. So x plus 14 equals 30, subtract the 14, and we've got x is equal to 16. So my solution was 16, 14. And remember, x represented number of quarters. So we had 16 quarters and 14 nickels for the coins that Walter has.